Hi and welcome to another live stream of UTA Planetarium. This is Levent Gurdemir, UTA Planetarium Director, and I'm here again with you with another great topic. So we are going to talk about exoplanets. Well, if you recall, in the past we talked about the solar system and we introduced a lot of things in the solar system. The sun is being the only star and planets wandering around the sun, and we talked about asteroids and Kuiper belt objects and comets and more. So astronomers and philosophers were always wondering if such things exist around the other distant stars too. Well, when we look at the night sky, we can only see the starlight, and it is not possible easy to detect if there are any things around these stars. But always we imagine that there are other star systems that have planets and perhaps asteroids and other things. So that's a pretty hot topic, because after a long time wondering about this fact, only 25 years ago, which is pretty much nothing ago, the first confirmation came about a planet orbiting other star. So it was only 25 years ago. So we can think that what was the big deal about not seeing those planets? Didn't we have access to great telescopes and what? So the problem was, even with the current today's great optic technology, and we have great telescopes on the Earth, we can only spot a few stars around nearby stars. And the reason is that the stars are too far, planets are too tiny to detect. And to be able to spot through a telescope, the planet needs to be very big and very apart from the star. But for example, if we think about Mercury and Venus and Earth in our solar system, they are pretty close to the sun. And if similar distance relation exists, then we will not be able to resolve it in the telescope, because the star brightness will take over the entire image. It will just saturate everything that is visible around it. In the meantime, well, I will introduce a special guest later today, but we have a comments chat. Please go ahead and post your questions in the comments chat so we can answer. And don't think that my question may be silly or anything. We'll answer all the questions. And also, no question is silly and no question is too complicated. No question is just don't hesitate. We would like to interact with you so we can see. And hi Jennifer, by the way. She says, yay, great. So I think we have great excited listeners here that we can talk about great things. So let's go back to the topic. So the direct detection of the planets around other stars is not easy. And 25 years ago, the technology just became available and accurate enough so we could measure the star's position or radial velocity very accurately. So why that was important? Because when planet goes around a star, and this is the same for our solar system too, what happens is the planet's gravitational influence actually makes the star wobble back and forth. So this back and forth motion, if we can detect that motion accurately, so we could 25 years ago, then because of this periodic wobble, is a great indicator for a planet or planet system around the star. So we can further analyze this and figure out how many planets are there and what's their mass and size, etc. So that technology improvement allowed us to start discovering those planets. So in 2009, NASA launched Kepler spacecraft, which used the spacecraft's dedication was to detect more and more planets around other stars. But Kepler used a different technique to do it. So, and that technique was, imagine a planet orbiting around a star, and when we see that star right in front of the star, so the planet actually obstructs little bit of the surface of star. So that obstruction, can we see that picture, Jim? Maybe I can explain it with better. So this was the wobble thing that I just talked about. So planet orbiting the star, and the star wobbles back and forth, and we are measuring that wobble motion. And here we go. We say we have a planet. But on the other one, the technique that Kepler used, which is called transient photometry, well, don't worry about the technicality or complexity of the term, but it means pretty much the light is obstructed by a planet. Let's switch back to the different picture, Jim, if we can. So here we go. This is very exaggerated example, but this is actually the Sun versus Jupiter. So when, let's say, Jupiter is going in front of the Sun and not from Earth, from another planet, let's say there is a life that exists and looking through the Sun, they will see the Earth, Sun, something like this, and the Jupiter will be obstructing little bit of surface of the star. So here you go. Some of the light is obstructed. That means little bit of the brightness will be taken away from the star. So if we can measure this little brightness difference, and again, that will be periodic as planet orbits around it. So here you go, we can also detect the stars, the planets that way. So if the planet is orbiting around another star, not around Sun, we do not call it planet, because the planet definition is pretty much reserved for our planets in the solar system. We call it exoplanets, which is actually short for extrasolar planets. And Jennifer asks, what is the nearest exoplanet system? We can probably ask that question to the guest speaker, but let me introduce him. So here with us today, and he is on the phone. Unfortunately, we had a technical glitch and we couldn't connect to his camera today, but UTA astrophysicist Dr. Manfred Cuntz with us. Well, he has a great research area, and by the way, when I came to UTA long time ago, I worked with him under his supervision. He was my thesis advisor, and we studied the extrasolar planets. So I have a long time history with him. So he is a physics professor, and he's teaching astronomy and astrophysics at UTA, both at undergraduate level and graduate level. And his research area is pretty interesting because he works on solar stellar physics, magnetohydrodynamics, stellar surface structure, extrasolar planets, stellar habitable zones, and astrobiology, observational programs, future NASA missions. And welcome, Dr. Cuntz.
Okay, welcome, Levent, for this very nice introduction. Yes, I think because of the technical problem, we just can deliver my voice today. But I'm very, very much excited to be part of this program, and I'm very interested and engaged to answer any questions audience may have.
Sure. Yeah, our first question actually came from audience, and if it is on top of your mind, Jennifer is asking, what is the nearest exoplanet system?
Actually, it's a good question. I think the nearest exoplanet system is regarding Alpha Centauri, which turns out to be a triple stellar system. And that is the nearest system. Based on my recalling, it's about 4 light years away. So that is the nearest system which has been discovered so far. And the point is also, I can say for sure, it will remain the nearest system forever and ever and ever, because that star is the closest star to us, to the sun, to planet Earth. So the closest star to us, or closest stellar system, as I said, it's a triple stellar system, is host to a planet. And yes, that is what we have found. It will be the nearest planet also for the many, many years of research ahead of us.
That is really great. So in your research of exoplanets, we hear the term habitable zone a lot. So could you please tell us, what is a habitable zone?
Well, again, this is a very interesting point. And roughly speaking, a habitable zone is a zone around a star which poses conditions for life to exist. So we have made studies about this regarding different types of stars. And it turns out if a star is more bright than the sun, the habitable zone also turns out to be wider, but also located further away from the star. Stars which are cooler than the sun, habitable zone turns out to be more narrow and also being positioned closer to the respective star. I think this is actually also a driver for a lot of research, because it also challenges us about thinking which type of life forms we should be looking for. But the traditional concept of habitable zone is very much informed by the types of life which we find with respect to planet Earth.
Okay, great. So you mentioned about life. So how likely we find life on those exoplanets?
Again, difficult question. So this is really one of the research topics ahead of us, and it seems to be that there is not a direct method for identifying life. So when we, let's say, take photos of extrasolar planets, and this is really an evolving area, so that is, we are just at the beginning to do this type of work. We cannot expect sheep and deer to greet us, or people to greet us. So we need to rely on more indirect methods. And the most popular method here is really based upon, I would like to say, the marriage between spectroscopy and atmospheric chemistry, which sounds a bit of complicated, but what we have to do is finding substances in planetary atmospheres which, to the very best of our knowledge, cannot be produced by a non-biological process.
Yes, and I remember these UV radiations. Or one of the study I got involved in the first place as the first-time graduate student was the UV effect. So the DNA damaging UV radiation of stars, which also exist from the sun, but mainly absorbed by the air on Earth. Mm-hmm. So we are not really getting our DNAs damaged, but this is also studied on different stars and planet systems too. So when we look at the list of those exoplanets, first thing we realize that the names are not really interesting. They don't have names like Venus, Earth, Neptune, or anything. They are usually a bunch of numbers, which are the catalog numbers of stars, and usually there is a designation with like B, C, D, E, F. So, and I'm wondering why there is such a name, or how they are named, and if I discover my own exoplanet, can I just put my name on that exoplanet?
Levent, I want to say you can propose this to the governing body, which is a working group at the International Astronomical Union. But the way it's actually being done is just a very, very few planets have really easygoing names, and sometimes those names are even not widely used by the scientific community. So what we do is we use a stellar name, which is again an acronym because of the catalog the star had been listed in, so an acronym, and for the planet, which is being first discovered in such a system, we use lowercase b. The next one gets C, D, E, F, and so on. So the numbers are, this is really cumbersome. It's not very attractive. But I want to say, getting back to the beginning of my sentence, for some of the most prominent planets, they do have names, but again, those names are not widely used, and I wouldn't even be able to recall some of those names. They had been proposed, they had been adopted, but again, most astrophysicists like to use a catalog number name with a lowercase letter in reference to the respective planet in that system.
But it is not likely. So that probably they will follow the convention. And when I studied the star, many of friends asked like, "What star are you working on?" And I said, "Well, my star name is HD 179949." And the planet was around it, named as HD 179949b. So that they really look at like, why did they didn't put any like an interesting or exciting name? But that's how it is. They go by catalog names. And thank you, Celeste. By the way, we have a thank you message from our viewers, and again, we are expecting your questions in the comments chat. Please share your question either with me or Dr. Manfred Cuntz, UTA astrophysicist. There's also a question from Peter. Says this is about today's such object, but last week in the east sky there was a very bright star that you couldn't miss. What was it? Well, probably we are talking about not a star but a planet. So the Jupiter is very bright in the sky. Probably that's what it was, Peter.
Yeah.
All right. So also in your research area, I noticed a term called exocomets. What is exocomets?
Well, an exocomet is a comet that is part of another stellar system. It's just an analogy of for planets if a planet is member of a foreign system, we call it an exoplanet. If a moon is member of a foreign system, we call it exomoon. And in case of a comet, we call it exocomet. And as it happens to be, yes, exoplanets have been discovered. There are very, very many, several thousands right now. Regarding exomoon, we have one discovery which continues to remain controversial, but actually it turns out we are a bit better off with respect to exocomets, even so we haven't seen exocomets directly, but we have indirect evidence for exocomets which essentially amount to the standard of detection. Why do we do this type of study? What is the point about it? The point is that exocomets are a candidate mechanism to deliver water to terrestrial planets. Water is very important for life as we understand. If there wouldn't be any water on Earth, life could not exist. Most, if not all, life forms do require water. So the study of exocomets is actually important for facilitation of habitability. It brings me back to a statement which I made earlier today. An object, a planet in a habitable zone, that's good news. It means potential for life, but the emphasis here is on the word potential. But in order for life to exist, the proliferation of water onto that planet is really instrumental.
We have a question from Jennifer. In the solar system, which planet has the most velocity?
Which planet has... Can you repeat?
Yes, in the solar system, which planet has the most velocity?
The most velocity, the most speed, I think that's Mercury. It is actually type of dictated by Kepler's laws. So point is, when a planet is further away from our sun, it has a smaller velocity on its orbit. Mercury is a planet which is closest to the sun, therefore it has highest velocity, it has highest speed.
Yeah, well, if our audience probably recall in the past videos we talked about, when we are talking about the solar system, we talked about the planets' orbits and orbital ratios are actually dictated by physics law or Kepler's law. And the closer the planet, faster it goes around the star. Sweta asks, do other stars also give off UV rays? It is asked by my 11-year-old daughter.
That's correct statement. That's a good point. Yes, all stars, virtually all stars, are sending out UV radiation. I would like to say there is a continuous level of UV radiation, but there's also episodes of beams of UV. I want to say. I recall that our project, which we did together a long time ago, so we were studying UV with respect to star-planet systems. And one point I wish to add here is that UV is very interesting because it is not absolutely clear whether UV is a friend or a foe with respect to life. Too much UV can destroy DNA, can destroy biomolecules. So if there's too much UV, life is, I wouldn't say prohibited, but made unlikely. But also it appears to be that at the very beginning of origin of life, a certain level of UV is potentially important because it allows the formation of macromolecules, molecules of biological relevance out of smaller molecules. So this is a very, very interesting area. Study of UV and origin of life, that is also one of the important topics of the astrobiological community.
Yes, certainly, and especially life in general, life in the universe is very interesting topic, which is also asked many times by our viewers. But also, so it has ties to astrobiology too. And speaking about astrobiology, do you have any hopes or big expectations from the recently launched Mars Perseverance spacecraft about finding life?
I don't know. So I'm open-minded. I'm interested in talking to colleagues and listening to the news. You mentioned Mars. I want to say Mars is actually, at least historically, from a planet formation point of view, the closest case to planet Earth. So when conditions were right on Earth for life to originate, similar conditions, broadly speaking at least, also prevailed on Mars. So it's at least worth looking and studying. One point to mention is, of course, based on all what we know, there is no surface life on Mars, but there may be life underground.
Great. Jennifer Jones is asking, what is the likelihood that we may one day explore and live on exoplanets?
Very small. They're too far away. So it's better to take care of planet Earth so that the need doesn't arise. So I would say that likelihood is extremely remote. Maybe a slightly greater likelihood, but still semi-remote, is maybe there is principal possibility in several millions of years, which is of course way past of our retirement, I guess, to colonize Mars or maybe some of the moons of Jupiter or Titan. This is at least a topic of debate, but exoplanets, I just don't see it.
Yeah, even the nearest star is with the speed of light, it takes more than 4 years to go. Even I cannot even take 10-hour flight to from here to Europe, so I don't see myself. Even we travel with the speed of light, which is not possible, but more than 4 years of travel time is not likely. All right.
I want to say there had actually been some calculations. Realistically, I would say travel to that place would take a few thousands of years because it cannot travel at speed of light. And the other downturn is that planet is hosted by a star which has a very, very high rate of X-ray and UV flux. And so it just wouldn't be a good place to visit. So better stay home.
Absolutely, and we need to take care of our Earth, and make it very livable place because it's our home. Dr. Cuntz, I would like to thank you very much for joining us with your expertise about the subject. And do you have anything to add?
Well, it was a pleasure to be part of the event, and I wish everybody the best, also considering the current health crisis. And yes, astronomy is a big field for the future, so UTA is a good place to study and to work. And once again, thanks for your time, and thanks for the good questions of today.
Great, and also we would like to thank you, our viewers, and our Planetarium staff, our program coordinator Jim Bader, and our moderators Jennifer and Huzaira. And see you next week. Thank you. Bye-bye.
Thank you.